Induced surface charge sigma. Now when we say that some charge has been induced in the sheet, then how much is that charge? We will have to find it. And let's say that charge is sigma. We have already calculated for a sheet of charges. Hopefully you remember that E is equal to sigma over 2 epsilon naught, and in some direction, let's say n head, this was the electric field for an infinite sheet of charges. And when we are having the electric field between two sheets, then this is double of this one, and it implies that E in that situation is sigma over epsilon naught and n unit vector. Means 2 times of this, so 2 will cancel. Now we know from our elementary electrostatic chapter that E is equal to the negative gradient of potential V. So I can write this one is in let's say, as we are talking about this thing, let me write this thing in one dimension. So this is curly over curly x, and this is V, and as it's a gradient, so I'm writing some unit vector with this one, some direction. And here, this I can replace the curly V over curly x, and this is an n. Now is this n is basically the normal to that surface. So the normal to that surface is, this is a surface, and now the normal to this surface is basically z axis. So it means this is curly V over curly z if I write, and then this is n head, means the n unit vector, and such derivatives I can replace that the concept of a normal derivative. Normal derivative means the derivative or the change in the perpendicular direction. So this one I can write that this is curly V over curly n. Now I don't need to write the n unit vector here, but this is the representation we usually do in calculus, that sigma is this is the normal derivative here. So I can write from this equation that sigma over epsilon naught is basically, let me write the minus sign as well. This sigma is, means sigma over epsilon naught is equal to this. So I can write that this implies that sigma over epsilon naught, or sigma, is equal to minus epsilon naught and curly V over curly n, or partial V or partial n, and this thing the normal derivative. While for in terms of z-axis, I can write that this is basically minus epsilon naught and curly V over curly z, and at z equal to 0, this charge is residing, because this sheet is at z equal to 0. So the charge is basically residing on the sheet, the induced charge, so minus epsilon naught curly V over curly z, and z equal to 0. Now we know from here the value of V, that this is the value of V. If I differentiate this thing with respect to z and then put the z equal to 0 in this one and multiply with minus epsilon naught, then this will give me the induced charge in this sheet. So let's go for this one. What about curly V over curly z? So we find this derivative. I can write that Q over epsilon naught is here, 4 pi epsilon naught is here. So this is q over 4 pi epsilon naught, and now I go is the denominator is having z here. So if I look here, this one is x square plus y square z minus d whole square, and it's having a square root. So when square root will go up, then it will become minus 1 over 2, and I will take the derivative of that one. So I take the derivative, so it will be the curly over curly z of this thing. So let me do this step quickly, because this is not that difficult. What it will become? It will become minus 1 over 2, and then this whole thing, and power minus 1 over 2 plus 1. So it will become minus 1 over 2 minus 1. It will become minus 3 by 2. And then I will take the derivative of this domain, and it's z square, z minus d square, so it will become 2z minus d, and then the derivative of z will become 1 and d will become 0. So I will get that this is 4 pi epsilon naught, and minus, because minus 1 over 2 was there, so minus will remain, and this is minus z minus d divided by x square plus y square plus z minus d whole square, and the power of it is basically 3 over 2. The minus we will have to keep in mind, its power was minus 1 over 2. So minus 1 over 2 will come in front, 2 will come in here, and when this 2 will be just here in the numerator, the 2 will cancel, but the minus sign will remain. So you can do this step very easily as just a single step here. So we have, and then for this one, also minus 1 over 2 will come, so that minus and this minus will multiply and it becomes plus. So we have plus, and this is z plus d divided by x square plus y square plus z and plus d whole square, and its power is basically 3 over 2. So this is the derivative of this equation, and now put z equal to 0 here. So we will put, when z equal to 0 here, then this will become equal, put z equal to 0. So this will become 0, and minus become plus, and this becomes d divided by x square plus y square and d square. So this comes out to be q over 4 pi epsilon naught, and this will be z is 0 and minus become plus, and d divided by x square plus y square, and when z is equal to 0, so minus d whole square is d square, and power 3 over 2, and the minus has already become plus here, and plus. What about this one? Z is 0, so d divide means we will get the same thing here, d divided by x square plus y square plus d square, and power 3 over 2. We should have done this step. This is also very easy, but as I have done it, so go on with this one. Look here, d and d divide the same thing, so it will become 2 times d, and it will simplify with this one. And another thing that came here, so it will become 2 times of that, and we will get that This is equal to 2qd divided by 4 pi epsilon naught, and this one x square plus y square plus d square and whole power 3 over 2. Now I can write the value of sigma. Sigma is minus epsilon naught times this. So sigma comes out to be minus epsilon naught curly v over curly z at z equal to 0. And this is equal, I will just multiply the result with minus epsilon naught. So minus epsilon naught, and then let me write the result. This is 2qd divided by 4 pi epsilon naught and x square plus y square plus z plus d square 3 over 2. And now there is some simplification. Epsilon naught goes with epsilon naught, 2 goes with this one is 2. So what we got the value of sigma. We got the value of sigma such that this sigma is a function of x and y only, because this is at z equal to 0. Z equal to 0 means this is just the sheet. So this is sigma xy, and this is equal to minus qd divided by 2 pi and x square plus y square plus d square whole 3 over 2. This is the value of sigma. Now if I want to calculate the charge, that how much charge is on the sheet, then I will have to do integration, and it's a sheet, so I will do integration on a surface, and then I will get the result of the total charge. So I can write that the total charge here is equal to the integral and sigma dA. Means I will integrate on the area. Now I know that what is the area here. The area is dA, it will be the area of the sheet, and this is dx dy. And the other thing is that this is the xy plane, and dx and dy, this is the area. But if I look here is x square plus y square plus d square, then the integration will be a little difficult. So why not to go to the polar coordinates? And the polar coordinates, the calculation are easy, and we know that the area in polar coordinates is equal to r dr and d phi. We are not involving theta here, because is r is there, r is equal to x square plus y square, and then the d phi, it will be integrated on 2 pi. So in the r is basically r square is x square plus y square. So putting these values, we will get that q is equal to, there are two integrals, and the two integrals are, the first one for r, it is running from 0 to infinity, while for the pi it is running from 0 to 2 pi. And we have the expression, the sigma r will come out to be, means this will be sigma of r and dA, and let me write the values. So this is minus qd, this is minus qd, minus q and d divided by 2 pi, and x square plus y square I am writing is r square, then d square and 3 over 2, while the dA I will write that r dr d phi. Now I know that there is no phi involvement here, means no integration on pi. So d phi when integrate from 0 to 2 pi, it will just give 2 pi. And when I come here, then look here that this is r square plus d square. When this will go up, then we will have r square plus d square power minus 3 over 2. And here the derivative of this one is 2r. So if I multiply 2 here and divide 2 here, then it will become 2r dr, and it is the derivative of this thing in front of it. And we know that when we are having a function, an integration, when we are having a function and the derivative of that function, then simply what we do in integration, we take the function and then its power is n plus 1 divided by n plus 1, and we are near to solve this thing. And this will come out, if you want me to do this step, then it is easy, but I think these two steps you can do very easily. That this will become r square plus d square and minus 3 by 2, so plus 1 divided by minus 3 by 2 plus 1. So this will become minus 3 by 2 plus 1, so minus 3 plus 2 minus 1, and here will also be minus 1 over 2. Now minus 1 over 2 and minus 1 over 2, 1 minus will cancel and this minus will remain. Let me do this so that the confusion is not that much. We have this thing. Let me simplify over here this one. When this 2 phi will integrate with this d phi, then it will give us 2 pi, and 2 pi will be cancelled with this one. So we are simplifying the things, and we are left with minus qd, and this is r dr. So this is integral from 0 to infinity, and here I will write, let me write 2r dr here, or let's say this one, r square plus d square, and the power is minus 3 over 2, and I am writing 2r dr here, 2r dr. So I will divide this by 2 as well. Now here the function, and the function in front of the function is the derivative of it, so it will be minus 3 by 2 plus 1. So I'm writing it here, minus 3 by 2 plus 1. So this is the function, and minus 3 by 2 plus 1, and here minus 3 by 2 plus 1. So what it will be? It will be the function power is minus 1 over 2, while here we will have minus 1 over 2. So minus 1 over 2 and minus 1 over 2, then the function, it will come out to be minus 1 over 2, so it become minus 2 divided by the function power 1 over 2. So we are having minus 2 above, and then minus then the function itself, and further we are having the limits. The limits are from 0 to infinity. So first we will put the 0 and then the infinity. So we have these very simple steps you can do easily. So I'm just means first you will put the value in the function r equal to infinity, and this will give you 0, and then minus, and when you will put 0 for r, then you are having only d square, and d square will cancel with this one, so you will get that this is qd, this comes out to be qd over qd over r square plus d square, and from 0 to infinity. And when you will put for r first infinity, then it will be something divided by infinity is 0 minus this value, so the minus will come in, and then minus qd by this. So you will see the first term is 0, so 0 minus, and then when r square is 0 here, so d square square root will come out to be d, dd will cancel, and you will have minus q here. And that is what we were expecting, that basically this charge induces an equal amount of charge but with opposite polarity. The induced charge is opposite to the source charge in the polarity but with the same magnitude, and this is what which we were trying to prove.